Hey friends, welcome back to another video. It's me, Ashul the Brilliant, and you're watching Learn with Ashul. And today we are going to be learning quadratic equations, right? So yeah, let's write that. We're going to be kind of like reviewing in one sense as well, and like yeah, we're going to be studying quadratic equations, right? So what are quadratic equations? What's a quadratic equation? A quadratic equation is an equation which has like the highest power of the variable in a quadratic equation has to be the square, like x squared, y squared, z squared, right? Because that is what variables are. Variable can be x, y, z. It doesn't always have to be x, right? It can be y and z too, but like that's a quadratic equation. And like if I were to give an example, basically what it means is like if I have x plus 1, this is, and like what makes an equation in the first place? The equal sign makes an equation an equation. Now if I have like x plus 1 is equal to 0, this is an equation, right? But it's not a quadratic equation. Now why is that? Is because I just told you the square of the variable is like essential, it's necessary for the equation to be a quadratic equation. And like the power can not be more than 2, right? But there can be other ones, like you can have, for example, you can have like 2x squared plus 3x minus 5, something like this, is equal to 0. This is a quadratic equation. It has a squared variable and it has like, yeah, it has some other variable. Like you could say it can have like x, like 3x, right? It can have 5x, whatever, it doesn't really matter. As long as it has a squared variable and nothing higher than that, no variable with a higher exponential power than x squared, then we're all good. We have a quadratic equation, right? And like examples of quadratic equations, I can give you like plenty of them, right? So that you can have like 5x squared plus 3x is equal to 0, something like this. You can have like 7x squared minus 2x plus 10, something like this, is equal to 0, right? And yeah, like these are a bunch of examples. You could have like, what's this? You could have like 8x squared minus 9x plus 13 is equal to 0. So like you can have these equations that are all quadratic. Why? Because of the squared variable. Square, 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 square. So yeah, these are all quadratic equations. Now, a special type of quadratic equation, basically, I'm gonna point out this one over here, actually. This quadratic equation. It's a quadratic equation, but it's a special type of quadratic equation. All right. This type of equation, it's a quadratic equation, but it's also known as a pure quadratic equation. I'm going to write QE for short, but like this is known as a pure quadratic equation. So what is this exactly? Like basically a pure quadratic equation is an equation in which the coefficient of the variable is 0, right? So like if I have let's say if I have like, 3x squared minus x plus 2 is equal to 0, right? And like in this, the coefficient of the variable, what's the variable? The variable is this x over here, right? So its coefficient is 1. You can see this is there's this 1 because, well, there's nothing we can see, so we can always add a 1 there, right? So like, yeah, we have minus 1x, right? Now, if I say like I have an equation 5x squared plus 3 is equal to 0, so there is no x term, right? Why is that? Because the coefficient of the x term in this equation is 0, so you can rewrite this as 5x squared plus 0x plus 3 is equal to 0. But now you can see there's no point of the 0x, right? So like you don't have to write it, right? That's why we don't write it. And that's what it means like to have like a pure quadratic equation. So that's like a type of quadratic equation is a pure quadratic equation. Now I'm just gonna take this example over here, which I also wrote. So yeah, like you can see this 5x squared plus 3x. This is a quadratic equation, but it's not a pure quadratic equation. Okay, so don't get confused. Over here, the coefficient is 0. Sorry, the constant is 0, but not the coefficient of the variable. So this is not a pure quadratic equation, it's just a quadratic equation, just like any other. Over here, these are quadratic equations, so this one is just a quadratic equation, just like that. Right. Now, there is first of all, we can generalize a like quadratic equation, or you could say all quadratic equations. We can write them in a general way, in a general form, and there's also a way of writing it, which is called the standard form, right? So it's called the standard form of a quadratic equation. And what is that? It's simply any quadratic equation in the form of, if it's written like ax squared plus bx plus c is equal to 0, provided that a is not equal to 0, it's in standard form, right? Now, if you can think about it, if you just look at it, just by looking at it, you know that in this equation, a is the coefficient of the squared variable, b is the coefficient of the variable, and, well, c is the constant, right? So, a is not equal to 0 means, if it is 0, then the coefficient of the squared variable is 0, so 0 is going to be multiplying with the squared variable, and that means there's, 0 squared variable. So that means there's no squared variable, no quadratic equation, right? Simple. So it must not, a must not be 0 for it to be in standard form and be a quadratic equation in the first place. And other than that, if, for example, let's say b, you could say the pure quadratic equation, right? So it's I'm just gonna take this color, pure quadratic equation. It's basically the same thing as this, just that there's no b, right? So you can write it as any quadratic equation in the form of ax squared plus c is equal to 0, provided that a again is not equal to 0. It's a pure quadratic equation, right? This is a standard. This one is the standard quadratic equation, the standard form of quadratic equations, and this is the pure quadratic equation, you could say the generalized version, right? Okay, so now we can also solve quadratic equations, right? And there are 3 methods that we're going to be talking about today. And the first method is called the factorization method, right? So number 1 is the factorization method. Factorization, right? And what does it exactly mean, right? What does the word factorization mean? Factorization, the word means to factorize, right? Factorize. And basically that is to find factors, right? And what are factors? Factors are terms. They're terms. Factors are terms which we multiply, right? So I multiply something by something and I get something. I'm just gonna fill this in. I multiply 3 with 2 and I get 6. So 3 and 2 are factors and they're multiplying to give me 6. Just like that, we have factors in quadratic equations. We get a quadratic equation by multiplying its factors, right? And I'm just gonna write a quadratic equation as an example, right? So I have x squared minus 7x plus 10 is equal to 0, right? And yeah, we're gonna work with this, right? So I have this quadratic equation, and in the factorization method, what we're doing is you can see over here why I wrote this is to show you you can see that we have 3 terms, right? We have x squared, we have 7x minus 7x, and we have 10, right? So these are 3 terms, and what we're doing is we're splitting 3 terms, so 3, or converting, you could say, actually converting 3 terms into 4 terms. And like we do it in such a way that like we split it in such a way like we're splitting the middle factor basically, right? And like we're splitting it into 2 terms in such a way that like those 3 terms become 4. The original 3, these are x squared minus 7x plus 3, plus 10. So like in this you can see like the x term is like the middle term is the x term, which is minus 7x, right? And like this term we are going to be splitting in, like there are 3 in all, and we're going to be splitting this term into 2 so that like in all there are 4. And when that happens, like in those 4 terms, there, like by splitting the middle one, we are going to get some terms that are going to be common. Like basically from the first 2 terms we're going to get something common, from the second 2 we're going to get something common, and yeah, like we're going to take that common and we'll get like the factors of this quadratic equation, right? So that like this is a quadratic equation, x squared minus 7x plus 10. When we split it, we get its factors, what it multiplies into to get us this equation. So the way we do that is like, first of all, number one, the first step is, well, to have it in standard form, right? So like we basically want to do this for all the methods, right, that we're going to be talking about. Like you want the equation to be in standard form before you start off. So like you know the values first of all, right? So like over here, just saying, we talked about a, b, and c, right? Up here, over here, a, b, and c. So a is the coefficient of the squared variable, b is the coefficient of the variable, and c is the constant, we said, right? So when we go over here and we look at this equation, we can like extract the values of a, b, and c, right? So like a will be equal to the coefficient of the squared variable. There we can't really see any. We can add 1, like I said. If there's nothing, we can always add 1 because it won't really make a difference. So a will be 1, right? Because it's the coefficient of the squared variable. And yeah, that's in this case 1. And like for the variable, what is b? B is the coefficient of the variable. The variable is x, its coefficient is minus 7. So b is equal to minus 7. And then c, what is c? C is the constant term, that's 10, right? Like this one. So c is equal to 10. Now, basically, yeah, actually, I'll just keep this inside. So like, what we want to do after we have the equation in standard form for the factorization method, we want to multiply the like coefficient of the squared variable and the constant. So basically we want the product AC, because like a multiplied by c is the coefficient of the squared variable multiplying with the constant, which gives us AC, right? So we want AC. What is AC now over here? A is equal to 1, c is equal to 10. So we get 1 multiplied by 10, which gives us plus 10. Now why I'm giving this plus 10, and like we're basically using this right here, right? So like if you know the sign, then like you can understand which sign the factors or the pair of factors will have. So basically what we want to do is split this. We want to split this 10 plus 10 into 2 factors which sum up to this minus 7, right? So like let me make the factors. So like the factors are, well, fairly simple. 1 multiplied by 10 and 2 multiplied by 5. So these are the only factors of 10, right? And like this result has a positive sign, right? And this positive sign, it's just telling us that the factors will have the same sign. Like both the factors will have the same. So if the pair is 1 and 10, then 1 and 10 will both have the same signs. And what sign is that? We can understand that with the sign of the coefficient of the variable, right? And that is like minus 7 in this case. So, well, I mean, like, yeah, you know, you can see this minus, right? So this minus means that those 2 factors will have a negative sign. So minus 1, minus 1, minus 1, minus 1. I mean, like, minus, minus, minus. So, like, yeah, like, we have a minus sign with all the factors, right? So, now, like, let's see which one sums up. Minus 1 and minus 10 makes, like, if you add them, you get minus 11. So, I'm just gonna like cross that, right? And minus 2 and minus 5, what does that give us? That gives us minus 7. So like if you go up here, we needed b, which was, well, like we needed them to sum up, the factors to sum up to minus 7. We already know that their product is like positive 10. We just need them to sum up to minus 7. Yeah, we got that, right? Because minus 2 and minus 5 is minus 7. So this is the pair, ladies and gentlemen. And like I'm going to split this 7 minus 7x into minus 2x and minus 5x. And yeah, the rest will just come like that. So like x squared minus 2x, splitting that minus 7x into minus 2x minus 5x plus 10 is equal to 0. And like you take x common from the first two terms. Like I said, we're going to be taking something common from like the set of two terms, and that basically means like this. For example, you can take like x squared and minus 2x, this is what it means, and minus 5x and plus 10. We can take something common from both of these, like, you know, separately. Like you could say x squared and 2x. So when we take x common, because x is common, we get x minus 2. Now from the second pair, you could say, or like the second last and the last term, we can take minus 5 common, right? And from that we can get x minus 2 as well. So now you see, I told you like we'll take something common after that. That's basically this x minus 2 and x minus 2, because it's common again. So like we'll take x minus 2 common, and yeah, we're left with x minus 5, right? So x minus 2 into x minus 5 will give us the above equation that we just factorized, which was x squared minus 7x plus 10. So yeah, that's like it. We got the factors. These are the factors, and now like you can see that they're multiplying with each other to give us 0, right? So that means like the equal sign basically is telling us that their product is 0, but like which one of these is 0? Like which one of these is equal to 0 so that we get a 0 on the other side? We don't know. So we are going to assume, right? We're going to say like either the first factor number 1, x minus 2 is equal to 0, or factor number 2, x minus 5 is equal to 0. In the first case, we can take minus 2 to the other side. When we do that, we get x is equal to positive 2, because, well, it's minus 2, so when it goes to the other side, it becomes positive. Its sign changes. In the second one, it also becomes positive, but yeah, we take like minus 5 to the other side, we get x is equal to 5. So like basically our solution set for x is 2 and 5. So 2 and 5 can be the values of like x that can be put in this equation, right? And like I just want you to notice one thing. Like you can see where like we solved a quadratic equation, which yeah, you can tell by the x squared, right? And basically it gave us two results. So from this we can conclude like that when we have a quadratic equation, we should get two results, which is not like always the case, because sometimes the result can be extraneous, and yeah, we'll like learn about that like later on. But I'm just saying that basically the degree of the polynomial, the variable can tell us, the highest degree of the variable can tell us how many results we're going to get in the end of the variable. So like in this case it was x squared, so two results of x, we got those, right? So yeah, that's the factorization method. Alright, so that's one method down, right? So time for the second one. The second one's name is the completing square method. And yeah, as the name suggests, we complete a square, right? We complete the square. Yeah, so what do we do in this? Yeah, I already said it, didn't I? We complete a square. And like, so how does it happen? Let's say we have like a quadratic equation, and like I'm gonna take the example of like x squared minus you could say plus 4x minus 437 is equal to 0, right? So the first step in this method again is to have the equation in standard form. And after that's done, because you can see we have it in standard form over here, because we have ax squared plus bx plus c, like, you know, on one side we have the terms, and on the other side we have 0. So yeah, it's in standard form. Now, like the next step in the completing square method is that we send the constant to the other side, right? And what's the constant term over here? It's minus 437. So let's send it to the other side. And when we do that, we can get x squared plus 4x is equal to positive 437. So it was negative over there. It was negative like on the left side, so it became positive over here, right? Simple. Now, like the next step is you could do like either before, right? So like you could if for example the squared variable, its coefficient is not 1, because in this case it's 1, so that's why I just like did this. I just like took the constant to the other side. But let's say the coefficient of the squared variable was like 2 or something, so then you would divide by this like coefficient of the squared variable, yeah, like before you like send the constant to the other side, or after you send the constant to the other side, before you actually begin to solve, because when you do, then it becomes like complex, you could say, in one sense, to complete the square. And yeah, like basically now we have like the squared variable, its coefficient is 1, we have the constant on the other side. The next thing we need to do is basically we want to complete this like formula, if you remember, because I'm pretty sure you do, from like pre-algebra. We remember the formula of a plus minus b whole square, don't we? It's equal to a squared plus minus 2ab, and yeah, you can see I don't have space, so I'm just gonna like move this a bit over here. Yeah, so plus b squared, right? This is the formula for a plus or minus b squared. So like we're gonna use the formula, and if you're confused about which like formula to use, the plus one or the negative, like that's simply indicated by this this sign over here of the variable's coefficient. So if it's like positive, that means you're using the like a plus b whole squares formula. If it's negative, then vice versa. And like also to find, basically, if you wanted this, we wanted this to be 1, because that way we already have the value of a. It's just x, right? So like a squared, this a squared, if I solve it, it will be x squared right now, right? And plus from the formula, and then 2ab, so it's a plus b whole square formula, so a squared plus then 2ab from the formula, then we have the a term, which is x. We don't have the b term, right? We can't take this 4x as the b term. That's it, because like, well, you know, it's not squared. How are you gonna, right? It's square, right? Because that can mess it up. So to get the b term, what you do is you divide the coefficient of the variable, which you can see in this case is 4, by 2. Whatever the coefficient, right? So like, let me just write like coefficient of variable. Like I'm just, you know, writing this as a like a to find like the value of b for the formula. I'm just like doing this, but like, yeah, you know that like the coefficient in this case of the variable is 4, right? So like b is equal to 4 over 2, right? Because like it's 4, it's divided by 2, so you get 2 ones are yeah, 2 ones are 2 and 2 twos are 4, so basically you get b is equal to 2. So the b term in this formula is going to be 2, right? 2. And just a minute. I just it seems as if I should take this a bit here so it doesn't interfere with our writing over here. So the b term is 2, right? We have that, and then like to complete the formula, we need the b terms like square 2. So like that's b squared is going to be like 2 squared, right? Because 2 is the b term. And then now look, we can back it up. We can like, if you look at this, we have like 2 and x and like 2. So like if you multiply the, like we got the b term, right? So yeah, like we if you like multiply it, this term, if you simplify it, you get 2 into x into 2, so that's 4x again. But like, meaning like up until this stage we can wrap this, but like this 2 square we can't wrap it up, right? Like we can't, like, I mean, like we can't like bring it back. There's gonna be like this type of inequality if we don't write the same thing or add the same thing on the other side. And for that, I'm going to add it on the other side. So 437 plus 2 square, because, well, look at this. 2 square over here, 2 square over here, they can balance out. If I don't write them, then, well, it's not going to be equal, is it, right? So, yeah, we did it, and now we're just going to wrap this formula up into this form, the a plus b plus minus, or like, yeah, a plus b actually in this case, a plus b whole squares form. So like that will be x, we have 2 into a into b square a square, so like you can say x plus 2 whole square, this is what the formula is of, right, is equal to 437 plus 2 square is 4. And yeah, we can just write it again. So like x plus 2 whole square is equal to, like, you add these up and you get 41. And like now you probably understand why we wanted the coefficient of the variable to be 1, because just you know, like, just think about it, the squared variable, because like if it was not 1, if it was like 2 or something, then you'd like send this to the other side, you'd solve that, and then you'd like have to, you know, get rid of this, the coefficient, whatever was over here, after getting rid of the square over here. Because what we're going to do to get rid of the square is simply square root on both sides, right? So x plus 2 whole square is equal to 441, and like under root. So like under root on this side, under root on this side. But since it's a quadratic equation, it should have 2 results. So that means the under root can be positive or negative, right? Like this 441, it will be positive, negative under root. And yeah, that basically that's what gives us 2 values in this, like using this formula, and or like using this method. And yeah, like over here you can cut like this square, and like the square root can cross out, and like x plus 2 will be equal to positive, negative, like 441, I believe it's the like square of 21. So yeah, we get like plus minus 21. And yeah, now we're just going to take 2 to the other side, basically to get the value of x, right? So like x is equal to positive, negative 21 minus 2, because, well, it's positive over here, it becomes negative over there. And yeah, so we're going to get x is equal to plus 21 minus, what's it called, 2, and x is equal to minus 21 minus 2. So x will be equal to 19, or x will be equal to minus 23. So there we go. We have 2 values again, right? 19 and minus 23. So these are the values of x using this method and using this equation. You could say like this example. So yeah. Yeah, that's pretty much it for the completing square method. And yeah, now let's get into our third method. Alright, ladies and gents, we have done 2 methods up until now. The next one is the quadratic formula. And basically, I did not do the completing square method in the, like, you could say, generalized version, and it's partly because of this. Like, the reason is kind of because of this. Because look at this. Now, if we like using the generalized version, let's say I have like an equation. Basically, we're just going to use the standard form here, right? So I have like ax squared plus bx plus c is equal to 0, right? So to use to get the quadratic formula for to derive it, basically it's derived from the completing square method, right? So like if I solve this equation using the completing square method, the first step, what is the first step? Now let's say the first step, since like I'm gonna do it this way, that I'm gonna like get rid of the coefficient of the squared variable. You can see it's not 1 right now, it's a, and this can be a problem, right? So I don't want that. I don't want a problem, so I'm going to get rid of it right here. I'm going to divide everything with a so that I get rid of a for like the squared variable. And when I do that, a and a will cross out here because, you know, a ones are a ones are a. So I'm left with x squared plus b over a x plus c over a is equal to 0, right? And yeah, this is the equation without a as the coefficient of the squared variable. And the next step I want to do according to the completing square method is to take the constant to the other side. The constant term is still c over a, and I'm going to take it to the other side. And its sign is going to change. So like I have x squared plus b over a, x is equal to minus c over a, because its sign changed. It was positive, it became negative. Right, now like to complete the square, I have like x squared as a squared, and then plus from the formula, and then 2 from the formula. How do I know? Again, it's this sign over here. It's a plus sign that I overdid, but like, yeah, it's a plus sign. That means it'll be a plus b whole square formula. And yeah, so like I have a squared, and then like I have 2, and then a again, which is x, and then b. What is b? How do we find b? We don't have b, that's why we need to find it, right? So how do we find it? Previously, I have mentioned b is equal to the coefficient of the variable. What is the coefficient of the variable over here? It's b over a, is it not? Yes, it is. So, like, yeah, you know, like, not to make it like complex, I'm just gonna write it like b over a divided by 2, like this, so that, you know, if any of you are confused about how I get this the value of b over here, you're not confused anymore after this. So like, yeah, we can get the division sign to become a multiplication sign. Oops, my bad. Over b over a multiplied by. We can convert it into a multiplication sign by, like, since 2 is like on the top over here and like there's 1 under it, we can flip it, because, well, yeah, you know, like whenever there's nothing under something, there's always 1, because 1 never hurts whether it multiplies or divides, because, yeah, it doesn't add, or, yeah, like, you know, like it doesn't help in one sense. Like, yeah, so you have like 1 on top of 2 now, and it became a multiplication sign. So the next step, I mean, like, yeah, you know, like solving this, we get like b over 2a, because 2 just multiplies with a, so you get 2a, b over 2a. So the b term is b over 2a, right? I'm just gonna write it over here, b over 2a. And like, yeah, I just want to show you, like, if you're wondering whether you're doing it right, you can always make sure like this. Look at this. Divide this 2 with this. This is just like because of like we have 2 and 2. But like, yeah, you can just like multiply this term, and if you get it, you get it. If you don't, then that means you probably made a mistake or you didn't understand it. And for that reason, you can always come back to this video. But other than that, we have 2 and 2. 2 ones are 2, 2 ones are 2. 2 in the numerator, 2 in the denominator. You cross them out, you get b over a x, don't you? Hence, we are doing it right. Next step is to add the like square of the b term, because we want to complete the formula of x plus b over 2a. So b over 2a whole square is equal to negative c over a. We're going to add the same square over, on this side, because we don't want no inequality. So b over 2a whole square. And yeah, we can sum this up into x plus b over 2a whole square. And maybe I like overdid it on this like division bar. Anyway, yeah, so like it will be equal to negative c over a plus, if we like, yeah, you could say like simplify it or expand it, we get b squared over 4a squared, because like b, its square is b square, and 2a square is like 2 square and a square multiplied together. So 2 square is 4, a square is a square, so 4a square. And yeah, we get like x plus b over 2a whole square is equal to, now like we are going to take the LCM over here, right? So let's take the LCM. The LCM will be 4a squared. And I'm going to write the LCM twice over here to divide both the denominators by, to find the whatever multiplies with the numerators, because we want to find what multiplies with this numerator so that it can come under the same hood as b squared. Or yeah, they can both come under the same over the same Vinculum bar. That's better, mathematically speaking. But anyway, so the denominator of c over a, the fraction c over a minus c over a, is a. So a will be divided with this denominator for a squared to find out what multiplies with its numerator minus c over there. And yeah, I'm just gonna erase that line. And we have negative c, right? And it's whatever is gonna multiply with it is gonna be found by dividing this. So a dividing 4a squared by a, we get a, and 1a from 4a squared crosses, and you get a to the first power, which is 4a, right? And you have plus b squared, and b squared is going to be multiplied by what? 4a squared. It's this 4a squared is up there, and this 4a squared from the denominator of b squared, which is this one, is going to be dividing over here. So when you divide them, 4a squared and 4a squared, when you divide them with each other, you get 4a squared 1s are 4a squared 1s are 4a squared. So you get 1 multiplied by b, right? And over here you're getting x plus b over 2a whole square is equal to, now yeah, let me just draw this line, 4a square. And yeah, now this let me choose this color. So minus c into 4a is going to be negative 4ac, is it not? Yes, it is. And why not? And 1 into b squared will be plus b squared. So I'm not going to really make a big change over here. X plus b over 2a is still going to stay there, and whole square over here. But I'm going to rearrange this by the positive term comes first rule, if that's a thing. Basically I'm just writing the positive term first. That's b squared. So b squared first minus 4ac second. And yeah, we're saving space. And other than that, we are getting closer to the end. X plus b over 2a whole square. Now, I think it's been enough. It's enough, I think we should get rid of this square. So we'll do it, right? Let's get it. B squared minus 4ac and 4a squared. And yeah, to get rid of it, we are going to have to take the under root on both sides. So we get under root x plus, in bracket, x plus b over 2a whole square. And we get positive negative under root b squared minus 4ac over 4a squared. Right? And this square crosses out with this square, so these two are free. So we get x plus b over 2a without the square. So x plus b over 2a is equal to positive negative. Now I can write this separately, right? I can write their under roots separately, or yeah, the square roots separately. So I can have just a minute. I think this is a bit off. Maybe it should be here. Anyway, yeah. So yeah, we can write them separately, right? So under root b squared minus 4ac and under root 4a squared. And x plus, by the way, yeah, you know what? We don't need to write this anymore since the square is gone. So yeah, basically we wanted the value of x, right? So let's get this b over 2a to the other side, right? And when we do that, we get plus minus b squared minus 4ac just stays in the under root because, well, it's stuck. You can't do anything about it. But 4a squared, you can do something about it. You take the square root, and basically 4 is the square of 2 and a square is the square of a, so you get over 2a, under root plus minus under root positive negative under root b squared minus 4ac over 2a. And this b over 2a becomes negative b over 2a when it goes to the other side. And yeah, so basically you can see that the denominators are same, right? This is 2a, this is, oops, that was my bad. But yeah, I accidentally clicked the button, I think. But anyway, this was 2a. Oh no, it doesn't seem to be working. Yeah, there it is. Let me just, there we go. So both of them are 2a, so the denominators are like the same. So we can like write them again under like one Winklen bar, right? Or division bar. So like plus minus b squared, like plus minus under root b squared minus 4ac minus b. And then like x will be equal to, like, again, now I'm just rearranging this. So like minus b plus minus b squared minus 4ac over 2a. So that's pretty much it. Now this end result is my no, not mine's, but like, yeah, the quadratic formula. And yeah, like that's pretty much it. So now, like, what I like about this, if you've like watched my other videos, like, I really like this because all you have to do when dealing with quadratic equations is pop in the values, right, of a, b, and c. And again, what are a, b, and c? A is the coefficient of the squared variable, b is the coefficient of the variable, and c is a constant. And you just pop them in here, get the result. Just put in their values. Well, that's if you have them, and you should have them. But like, yeah, just saying, you get the value of x quickly. But still, it's always a good thing to practice all the methods. So yeah, like this video, its purpose was for you guys to understand, for like me to build your concept about the three methods that like we talked about, and quadratic equations in general. And yeah, like it's good to practice all three of these methods so that you get good at all of them. And yeah, you know, like how to solve quadratic equations using all three of them. And sometimes like some method might not work, so that's when the others come in handy as well, right? If you have like a go-to method, like for example, if you really like the quadratic formula, or if you really like the factorization method or something, or you know, the completing square method, then like, you know, if it doesn't work sometimes, then yeah, you can use any of the other ones. So yeah. Anyway, that's it for this video. Thanks for watching. I hope you learned now, because I'm really sure of it. Whatever I've tried to give you the knowledge of, you should have it. If you have any confusions, rewatch the video. If it still doesn't go away, then just, you know, comment down below. Message me. I'm ready to get back at you and give you some advice. Anyway, yeah, as always, it's me, Ashur the Brilliant, and yeah, peace out.